Welcome, ladies and gentlemen, to our discussion on how to predict the products of double replacement reactions. So after having done our solubility lab, you should be familiar with the idea that just because we mix two ionic compounds together doesn't guarantee there's necessarily going to be a reaction. And what we've identified is that the property in question is solubility. So we spend time in our lab identifying the solubility patterns of certain ions, which is something that scientists have also done as well. So we are going to be able to use the solubility rules, and there's a couple different forms of them that you have access to. One is the chart that you see visible here on the screen. This is in the same packet that your activity series resource is in. So we will be using this chart to identify characteristics of the products. Okay, so remember, we kind of know already that our reactants are going to be aqueous. We're looking to see, is there a precipitate possible in one of our products? There's also a set written more as a hierarchical set of rules, whereas you work your way from top to bottom. When you hit the ion that is applicable to your product, you apply that rule at that point. If that's something you want to look into, please see me during class and we can talk that over. Now, steps we need to follow. With predicting the products, it's a little hard to see it ahead of time. So the first thing that you want to do is actually write what the products would potentially be, making the switch so the cation and the anion have new partners. Once I know what the formulas of the products would be, then I use the solubility chart to determine what state the compounds formed would be in. If we find that both of the compounds produced are aqueous, nothing has actually happened. They're still actually all existing in the same way they were before, just now there's more things in that solution. But if we identify that a solid, liquid, or gas was produced, that is a new substance that's carrying a new state of matter. We would then follow through and balance the reaction identifying that it occurred. Because states of matter are so important for this type of reaction, you must include the states of matter in all of these types of reactions. Realistically, you should also be doing that for your single replacement because it helps to identify the changes in those as well. So let's take a look at some examples. I've also added in another visual just now for the solubility chart. So as we look at our products, you should follow along and follow the same chart that you have. So when I look at the sodium nitrate and the magnesium bromide, the sodium is going to bond with the bromine, and they both are +1 ions. So my formula would be NaBr. Now the magnesium is a +2 and the remaining nitrate is a -1, so I'm going to need 2 of the nitrates in the formula. So now I'm going to look for my sodium bromide on my chart. So I'm going to find the intersection between sodium, which is on my left-hand side, and the bromine, which is across the top. So as I scroll down, notice that bromine is the second column. And when I get to sodium, I see that it forms an aqueous substance. So when those two are bonded together, aqueous. So far, potentially not a reaction. Now I'm going to find the intersection between magnesium and the nitrate. So over here, as we follow down, magnesium also makes an aqueous solution when bonded with the nitrate. So since both substances produce aqueous products, therefore there is no reaction. So now let's try the next one. In this case, the calcium and the sulfur would bond together. leaving the chlorine and the lithium to bond together, both +1 and -1. So let's look for our calcium sulfide. So I've got calcium here, I'm going to come across all the way to the end, and we'll see that our calcium sulfide does make a solid. Now it is good practice to also confirm the other substance. So let's find our lithium. And we're going to take that over to our chlorine, and we see that's aqueous. So since this reaction happens, now we're going to balance it. And the only thing I'll need to do is put a coefficient of 2 by the lithium chloride to balance out the ones on the left. So our process is that we make the switch, we show what the products would be if it did occur, and then we use our solubility chart to identify if any of the products form something other than an aqueous solution. If they do, I finish my reaction and balance it. If they don't, I simply cross it out and write no reaction. So at this point, you should be able to now do the third page of your practice packet with predicting the products. And we will continue with decomposition after we learn about net ionic equations, which is another application of double replacement reactions.